Okay, now we created a problem 2 by substituting here infinity. Now we are going to do the same problem, same method. So we are going to allocate 0 in all rows and columns. To do that, we need to first start with rows. Okay, so first the minimum element is here 6. So you're going to subtract this 6 from all the elements. So this will change us. So here is infinity 4 0, here it is 6 minus 6, and 9 minus 6 is 3, and here the minimum element is 2, so it is 3 infinity 3 2 0, and here the element is 4, so this will be 0 5 infinity 3 4, and here the minimum one is 1, so 6 0 2 infinity 3, and minimum is 2, so 1 0 5 4, sorry, so this is 4, this is 3, sorry, 4 3 infinity, and okay, now we need to check whether the zeros are in each column. One row, second row, sorry, first column, second column. Here there is no zeros in the third column. Fourth column, fifth column have 0. So now we need to change this third column. The minimum element is 2, so 2 will be subtracted for each column. So I'll make it quick. So third column is will be infinity 1 infinity 0 2 0 2 3 infinity 3 3 0 4 3 infinity. Okay, so now we are going to start the allocation of zeros. So zeros will be allocated here. So for allocating 0 here, you will get first 0 will be allocated here, and there is no zeros in the same row and column. Okay, now allocating the 0 for the second row, so this 0 will be allocated here, and there is no 0 in the same row and column. And for this row, this will be allocated, there is no zeros. And here, as we see the same case there, if I allocate this 0 will be cancelled, and there will be no 0 to allocate in the fifth row. So I'll choose carefully, prudently this 0, so that I may have the 0 for the fifth row. Okay, so now this 0 will be cancelled, since there is 0 in the same row. Now this 0 is allocated for the fifth row. Okay, now we have 1 0 in first row, second row, third row, fourth row, fifth row, and in all columns. Now our problem is over. Now we are going to see the tour. Okay, so the tour formed as here. Let us allocate. This is right. The city is A, B, C, D, E. Similarly, A, B, C, D, E. Okay, now so here too we are going to write a tour. So let us start from A, right? So from A to, we have, from the tour is A to D. From D to C, so from D to C, and then so C. So it ended with C. Now we need to start with C. So C to A. C to A. The tour ends. Next to start second city. After A, we need to start with the B. From B to E, E to B. Right. So this is the second program, and here also we had a subtour. So it's a very typical problem as we see here. Now again the same procedure will be followed as we did in the first problem. First problem. So what we had there, so we just target this subtour. So here B to E is 2 and E to B is 2. So here the z, the z value for this tour is 6 plus 3 plus 4 plus 2 plus 2, and therefore it is 17. Okay, so z value for this problem, it is 17. So here just compare these two values. It is a lower bound and we don't know that is upper bound. Let us see. Okay, so let us proceed with this problem 4 and 5. So let us go move with the problem 4, and we have here db equal to infinity. So we need to make this db equal to infinity in problem 2 question. So our problem 2 is here. Problem 2 is here. In this we need to make dbe. be is here. So this will be infinity. Now we'll write a problem 4. Now we are going to move this problem 4. So we have here infinity, db equal to infinity. The same procedure. So first the rows should be in zeros should be in all rows. So here as we proceed here, 6 is the minimum element, and subtracting that will get 4 infinity 0 3, and 4 is the minimum in the second row. So 1 infinity 1 0 infinity, and 4 is the minimum 0 5 infinity 3 infinity, and 1 is the minimum 6 0 2 infinity 3, and 2 is the minimum here 1 0 4 3 infinity. Okay, right. From this we need to check whether there is zeros in all column. So 0 in first column, second column, fourth column. There is no in fifth column, and third and fifth column doesn't have zeros. So we'll change that here. So this will be and infinity 1 0 6 1 4 infinity 5 0 0. Now change the third column. 1 is the minimum, so subtract 1 from remaining. So 0 infinity 1 3, and fourth column will be as it is, and fifth will be 0 infinity infinity 0 infinity. Okay, now we'll start allocating the zeros. So for allocating the first 0 here, if I allocate, you can choose anything, and if I choose this, I will cancel this. So there is no problem, we have another 0 in the fourth row, and if I choose this, if I cancel, we have another 0 in the second row. So it is fine to allocate any one of these. So let me select the first here and cancel the remaining zeros, right, and then here. Okay, now go with the second row. Here we'll allocate this 0. There is no zeros in the respective rows and column. And for the third row, and there's no zeros in the column here, rows. And here if I select this, again we have the problem as we had earlier. This will be gone, and there is no other 0 in the last row. So prudently I select this and I cancel this, and now for the fifth row I'm selecting this. Okay, now there is zeros are there in all rows and all columns. Okay, so let us find the tour. So we have the tour as starting from A. I'll write A, and before that let me write the cities A B C D E, and here A B C D E, right. So from A to D we have A to D, and from D to E and D to E, and from E to B, actually add to B. So from B to C, B to C, and C to E. Finally we reach the single tour in the program 4, and therefore now we need to find the optimum distance, right? So for A to D it is, for A to D here it is, for A to D it is 6, so I'll write 6 here, and for D to E, it is 4, and then E to B it is 2, B to C it is 0, see here it is, sorry, B to C is 5, B to C is 5, and C to A, so C to A is 4. So I think everything has been noted down. Now we need to add it. Okay, so Z value equal to, we have here 6 plus 4 plus 2 plus 5 plus 4, and if you add it up here, 10, 17, 21. So this program 4 has the Z value as Z equal to 21. So this is the upper bound I give. Okay, now what about the cases of these two programs? Actually we need to find what happened to these two are also, right? But we have reached the program, but anyway we need to finish it off. So to finish this, let us move on to the program 5, problem number 5.